All right, so the expansion contraction solver is a new solver for BloodHound version 2 only. So back in BloodHound version 1, every once in a while, I'd get somebody asking, how do you identify, mainly if something like the Bollinger Band was expanding or contracting, or maybe something like the MACD BB, which the MACD BB is again the Bollinger, merged together with the MACD indicator. So it has expansion contraction lines, or maybe somebody has a modified Keltner channel as well. And I think even maybe the VWAP indicator might have expanding, contracting, because it uses the standard deviation lines there as well. All right. So yeah, back in BloodHound version 1, there was limited ways that you could do that, but it wasn't perfect. So it's about time that we actually added this new solver here. And the name basically says everything that it does. It identifies if two lines are expanding or if two lines are contracting together. And there's really not too many settings for it. All right, so we can either right click on the workboard here and go to solvers, or again, you do have the list of solvers here from the menu ribbon. So this is called the menu ribbon. All right, so let's put that on there, the expansion contraction. And I'm going to name the tab here. So we'll name the tab. There we go. Okay. All right, so this one will be the Bollinger expansion contraction. All right, we'll connect that up to the result node, and then, right, so obviously you need two inputs, right, or two plot lines. So we have input A, input B. So input A is, it doesn't matter, but if you are working with something like a banded indicator, right, then you would typically put the upper band into input A and the lower band into input B. All right, so let's go ahead and do that. There we go. So there's the select indicator window. There's the Bollinger. And I'm just using the default settings here. So we're going to select, make sure the upper band is selected first, and it is. So we're good to go there. And actually, let me just double check, make sure the Bollinger on the chart, yeah, it's 2 and 14. Okay, so standard settings. All right, so now for input B, that will be the lower band here. There we go. Add the Bollinger down there again. And this time we're going to add the lower band, like so. And there we go. So by default, right, the solver is set up to give you a short output when it's contracting, right, and a long output when it's expanding, just so that you can, quickly visually see, that your inputs, are set up and working there, right? So, but, it should be obvious that if something is contracting, that doesn't mean the market's going short, right? And that just means there's less volatility, at least with the Bollinger, right? And if something's expanding, usually that means the market volatility is growing, and so that's not indicative of going long. So I'd say the majority of the time you're going to want to go into the output section here and change things, right? So expansion and contraction has nothing to do with market trend direction, right? So from that standpoint, you're most likely always going to want to open up the rules window here and decide what are you actually trying to identify. Is it, expansion, or are you trying to identify contraction here? So let's say we want to identify expansion. Then, well, we can see the long output as I just explained, the long output by default is identifying expansion. But the short is identifying contraction. So let's switch the short side to expand, like so, and then hit the apply button, right? And so there we go. So now what we're identifying here is whenever the Bollingers are expanding, right? So there's no output, right? So when there's no output, either the Bollinger is contracting or it's moving in parallel. Right? So yeah, so you're going to set the expansion contraction solver up to either identify one or the other, and you're going to want to have this long and short output at the same time, again, because expansion and contraction doesn't tell you market trend direction, right? It just tells you volatility is increasing or decreasing, right? So the other parts of your system will identify the market trend, right, and then filter out either the long output or remove the short output, right? So bottom line is you want the expansion contraction to give you a long and a short output at the same time. All right, so that's expansion, and we'll just take a quick look at contraction. There we go. So basically that's kind of the opposite there. So, and then the other condition you can look for is parallel. And I would not expect the Bollinger to be parallel. Oh, there we go. Actually, we do have one situation where it is parallel. Interesting. All right, yeah. So from that point to that point, and then that point to that point, they actually moved exactly the same amount. So we had one bar where those bands were parallel and not expanding or contracting. So, right. I think so far, from the kind of the questions I've had in this workshop, probably using the parallel is probably going to be more common when you're using this to look at two moving averages. So let's kind of do that. Let's take a look at that as one of the examples here. I'm going to put this back to expanding here. There we go. Put that off to the side. So let me go add a couple of moving averages to the chart. All right, so we have a couple of slower moving averages here to help exaggerate, right? So we have a 100 period and a 200 period SMA there. So let's go make another solver with those two indicators. So solvers, and there you go, expansion, contraction. All right, connect it up, and then let me plug in the inputs here. So I'm going to put the faster moving average in input A. All right, so that was pretty easy. All right, so for input B, we're going to set this SMA to the 200 period, like so. And again, we can just quickly kind of take a look at this and make sure it looks like we have the input set up correctly, right? Because we know that by default, the expansion contraction solver is going to give us a long output when the two plots are expanding away, and and a short when they're contracting. So let's see, right? So we actually have a few bars where they are contracting. Yeah, and you know, it is too hard to actually see unless we expand this out. There we go. Really exaggerate that. Yeah, so obviously we can now see as the market, all right, moved up, right, or pulled back, then obviously that pulled the SMA 100 up just ever so slightly, while the SMA 200 was still kind of curving down. So there we go. So there's our contraction, or the two SMAs basically moving back towards each other. There. So let's go into the output here. And as mentioned before, let's take a look at the parallel there. And wow, I kind of thought there'd be more bars where these two SMAs might be parallel, but I'm not really seeing anything. So only that one bar there. So from the bar prior, right, to this bar, those two SMAs were basically perfectly parallel. So, all right. Oh, there we go. There's a few more instances. Stretch that out. Yeah, so there we go. Oh, let's take a look at some other settings here within the output window, right? So something else you can do is let's take a look at expanding, right? So you can see, towards the end of the settings here, towards the right, that you can actually put a modifier on here. So you can check to see if the two lines are expanding at least a certain amount. So let's see, we have points. So let's see if there is any situation where these two SMAs are expanding away from each other by more than 1 point. And then we'll kind of explain or discuss what that means. There we go. Yep. So as the market kind of fell off here, right, and it pulled that 100 SMA down pretty quickly, and obviously the SMA 200 is taking a little bit longer to catch up. So what we have is, all right, I'll try and get that as precise as I can. There we go. Right. So, when you're doing expansion contraction, right, you're taking the distance between the two lines of one bar and comparing it to the distance here between the next bar, right? And if the length is growing, right, then they're expanding. If the length is shortening, then they're contracting. So now, if we take these two lengths and there we go. That's pretty good. So if we look at the top right and take a look at that, the difference between those two lengths, right, the difference is greater than 1 point, right? So that's what we're looking for. So we're looking for a difference, right, between input A and input B of at least 1 point or more. Yeah. So if we measured those two lines, we would see that, right, the longer line is at least 1 point longer than the shorter line. So that's how you would calculate if these two SMAs are expanding by at least 1 point or more. Okay. Now, we could do the opposite and say, okay, we only want to know when these two lines are expanding by a minimum amount here, or in other words, at most 1 point. So the expansion cannot be more than 1 point, right? So it's, in other words, this would be looking for a very small amount of expansion. So let's hit apply, and as you might expect, right, it just reverses everything. Well, not a complete reversal, but it when the two lines are expanding, and remember in here it was contracting. Yeah, it was contracting within there, and so now we can see it is expanding here, right? And so we're now identifying when that expansion is less than 1 point from one bar to the next. And then when that expansion gets too large, right, then there's no output. So this expansion, as we looked at first, is, the two lines are expanding greater than 1 point. So probably the typical use case here is if for expansion is commonly going to be used to identify that volatility is expanding, right? I mean, that's what the Bollinger Band is doing. If you're looking for volatility expansion within your system here, then you're probably going to use the expand at least. You would use the at least far more often probably than the minimum, right? Because you might be saying, okay, my system needs, works best when there's extreme expansion, within the market here. So let's go back to the Bollinger here. Let's go back to the Bollinger. So with the Bollinger, let's see if the Bollinger expands more than 5 points. So there we go. So we can see right here, right, that really long down bar, right, made the Bollinger Bands expand extremely, right? You can see the upper band shot way up there, right? So it was contracting pretty tightly, and then we got that that big volatility large bar, right? And then the expansion really expanded there. So here's at least all the places on the chart here. So right there's some situations where that Bollinger is expanding pretty extremely there. So 5 points or more. And I'm still in the habit of double clicking here. So so just another little side tip here. You don't have to double click. You can just a single click actually highlights everything. So if you do double click, it does reduce this panel here. So let's see what else. Right. So so the reverse would apply to contraction. So I guess we'll just kind of run through contraction real quick. Okay. So let's see if there's any contraction that's greater than 5 points. Oh, there is. Okay. So probably because of the upper band. So we can see the upper band here. Let's get rid of that. And we can see the upper band is pulling down really significantly, right? Whereas the lower band, yeah, it's pulling in a little bit. So the upper band is probably what, well, not probably, but the upper band is, what's causing this contraction that's greater than 5 points, right, from one bar to the next. So there you go, right? So you could do the opposite and identify extreme contraction, right? Basically identifying that the market volatility is kind of shrinking. So again, this has nothing to do with the market trend, right? Obviously, we can see the market is still, zigzagging downwards, right? It's still pulling downwards here. But as far as the volatility that the Bollinger Band is identifying for you, right? That volatility is shrinking here dramatically by at least, I keep double clicking there, but that the contraction is shrinking by at least 5 points or more. So, right. Let's see what else here. Yeah, I guess just to go over this real quickly here. As with all of these rules windows here, right? You do have different measurement units here. So this has points and ticks, right? So you can check whether something's moving in points or ticks, like so. And let's see what else. All right, yeah, so one more example here. So every once in a while, I'll get this kind of question here, where most commonly the question is about crossovers, usually, right? Where people want to identify when, two totally different indicators, I should say, are crossing over. So I'm not going to do the crossover, but I can see that somebody might be thinking along the same lines here, as using two different indicators and seeing if they're expanding or contracting here. So let's close this out. All right. So I have the CCI and then the stochastics, right? So while I can overlay them on top of each other, and NinjaTrader makes them look like they're in sync with each other, but mathematically they're not in sync, right? Because you should know that the stochastics doesn't go below 0, right? The stochastics goes from 0 to 100, but the CCI goes positive to negative, right? So we can actually see the 0 line right there. I left the 0 line visible here, for the CCI, right? But the stochastics doesn't have a 0 line because it doesn't go below 0, right? So these are two different indicators, but because NinjaTrader allows you to overlay them. So let's open up the indicator settings here to see how I did this. So, right. So if you have two indicators on top of each other and one of those indicators is set to overlay, and this might apply to, maybe you need one indicator set to the right margin and the other indicator set to the left margin, like so. That's right. Yeah, if I use the left margin, it's going to look pretty close to the overlay. So, right. Right, so you kind of get that same effect, right? So in other words, if both of your indicators aren't both set to the right margin, then chances are you're using two indicators that are mathematically not using the same numeric value system, right? They have different, they're outputting different values that just really can't be compared to each other. Okay. But yeah, so that's what I have going on right now, right? The stochastics is overlaid. Now, so this is most likely not going to work with the expansion contraction solver. And it's really not going to work with any kind of solver. Yeah, so as I kind of mentioned, usually I get asked this about, trying to identify these crossovers. And mathematically, they don't cross over. So that's why you can't use a crossover solver on these here. And actually, yeah, here. So if I move this, let's see. Yeah, there we go. So you can see, right, that crossover has now changed, right? If I move this back, all right, that ellipse is a little difficult to work with. So let's put a dot. There we go. Let's put that dot on there. So now if I move this, right, that dot's now in the wrong spot. So that's a good example that the two indicators are mathematically not in alignment with each other. So you can't really do a crossover. And the expansion contraction may work, it may not work. It depends on how extremely different the values are between the two indicators, right? So the stochastics goes from 0 to 100, and the CCI goes from positive 200 to maybe negative 200. So they might be close enough where the expansion contraction may work, but I wouldn't expect it to be very reliable because of the value difference, from the stochastics, being limited between 0 and 100, right? But the CCI can go, up to positive 500 or negative 500, right? So extreme differences in value can occur between the stochastics and the CCI here. But so let's just take a look and we'll see what happens here. Let's see. So I'm going to put the stochastics in input A because it has the least amount of movement. All right, so I am just using the standard stochastic settings, and we'll take a look at the %D. Actually, let me just double check. Yeah, let's see. Yeah, it is the %D that I have showing on the chart. All right, so input A is the stochastic. Input B, that will be our CCI. All right, CCI only has one plot. We're good to go. And so we can see off the bat that it is identifying, some expansion and contraction. But, whether it's mathematically always correct, that's could be a totally different issue. So let's take a look at expansion here. Yep, and good. I think I found a good example already. So yeah, so luckily we are kind of visually able to see that actually, what we're seeing on the chart, those are actually contracting. Now again, if I move this from side to side, if I move her from side to side, right, obviously, the indicators move off of these lines here, but still, this is a good visual here. That visually they look like they are contracting, but the mathematics, because they're on different scaling systems, right? The y-axis scaling is different between those two indicators. That mathematically they kind of came out to be expanding, but obviously that's not what we're seeing on the chart. Right? So yeah, just kind of keep that in mind, that none of the solvers can back engineer this illusion that you can create with two indicators, right? So the fact that NinjaTrader allows you to overlay one indicator on another, right? And you can see those crossovers, or you can see those expansion contractions. That's an illusion created by NinjaTrader, right? By overlaying them on top of each other. Right? So, let's see here. All right. Now, that kind of leads me into the one setting we haven't covered yet, which is the calculation type, right? So we have slope delta and distance delta here. And actually, let's switch this over to distance delta. And okay, so yeah, quite often, depending on the two indicators you're looking at, especially when you're looking at two indicators that have a different y scaling there, you will see a difference between the distance delta and the slope delta, right? So the distance delta is pretty simple and pretty direct, right? Basically, you're taking the distance, as I've tried to use these vertical lines here to show, right? You're taking the distance between the two lines and comparing them from one bar to the next to see, is that distance shrinking or expanding, right? So that is probably the more direct way that people think of expansion or contraction. Again, let's kind of go back to the Bollinger indicator here. Actually, let's open that up. Yeah, make these plots a little thicker. Yeah, there. All right, here's a good example. Yeah, so most people are going to be thinking of expansion contraction by taking the difference, right, or the distance between the two plots there, right, and then comparing them, right, taking those lengths there, right, and checking the length of one, comparing it to the length of the other, right. If the next one is longer, then it's expanding. If it's shorter, then it's contracting, right? So that's just the straightforward formula for. Let's open this back up. Actually, let's connect the Bollinger back in here. Right. So that's the distance delta there. Right, delta meaning the difference between those lengths there. So now slope delta is actually calculating the slope of the two lines and then comparing those slopes to each other, right? So that's a much more complex formula there, and the Bollinger will actually provide some good examples of the different formulas. So the slope would be there. You take that and then compare it to that, So let me, shoot. Yeah, I wish Ninja would kind of give us finer control over these drawing objects. There we go. Right. So if we take the slope, and I don't use the word angle because there really is no angle in charting, right? So for example, yeah. So here's the reason why I never use the word angle, because that looks like a 45, right? What if I do this? Well, that looks like an 85-degree line now, right? So the angle just changed dramatically, right? It went from almost, right, it's almost 90, right? So it's about 80, 85, right? So it went from, close to 90 all the way down to now like 45. So there is no such thing as an angle when it comes to charting, but there is slope, right? And slope is just measuring how far something moved up or how far something moved down, right? In either points or ticks up or down. So the slope delta, is looking at, the slope of one line, comparing it to the next line, and seeing is that slope, increasing or decreasing. So actually, sorry, we're missing a component here. So, yeah, sorry, in order to do slope, we actually need 3 bars to do slope, right? Because the slope requires 2 bars. And so you're taking this, come on, there we go. There. So you're checking, right, the slope of the previous 2 bars to the slope of the of the next 2 bars, and you're checking to see if those slope angles are expanding or contracting. And actually, yeah, we can actually see here when we put these really close to each other that actually the prior bar was contracting, and we can see that obviously the next 2 bars here are expanding. So that actually wasn't a great example. Let's see here. Slope. Yeah, actually that's not a good example because I only have 1 bar of expanding. Oh, that's because it's set to contraction. All right, so yeah, it actually was contracting. There we go. Let's put that back to expanding. There. All right, so I'm just going to get these lines set up again. There we go. Okay, there. So now we can actually kind of see the slope delta here, right? So we can see the difference in, these 2 slopes versus the difference in those 2 slopes, right? And we can see that the slopes are expanding, yeah, just as simple as that. So, all right. So that's how the slope delta works versus the distance delta, right? So again, just to recap, distance, you're literally, measuring the distance, in other words, the y-axis, right, between the input B to up to input A, right, and just comparing those two lengths, whereas the slope, that requires an extra bar. In other words, that requires 3 bars, because to get to slope, you got to go from one bar to the next, right? So that requires 3 bars there, and you're looking at, you're comparing the difference or the delta of the slope, between the prior 2 bars to the next 2 bars, and seeing if that slope is expanding away or contracting towards, right? So, let's see here. The slope delta. Yeah, I don't have a good example of where the slope, of what indicators the slope delta would be used for, but I'll go back to kind of like, this bad example here, where you've got 2 indicators overlaid on top of each other, but this is the kind of situation where slope delta, might be required, because measuring the distance between those, it's just too chaotic. Again, chaotic because the CCI goes negative, right? So in some situations, right, the CCI here is negative, right? Because remember, that's the 0 line, right? So we're taking a negative number, and comparing it to a positive number for the stochastics all the time there. So again, this is not a great example, but hopefully it does kind of illustrate the point there of why when the measurement units between the 2 indicators are such that the slope delta formula would work better versus the distance delta. So, all right, yeah. So that's a breakdown between the calculation types, and then that concludes it. Right. So that's really all there is to the expansion contraction. It is one of the simpler solvers that BloodHound has.